To connect the resistors in parallel, you join all the leads on one side of the resistor together to a common point. In this example, we have the left-hand side of R1 and R2 joined at point A. Then we have the right hand of R1 and R2 joined at B. This creates a parallel connection of R1 and R2, and we're trying to find what would be the equivalent resistor of R1 and R2 in parallel. We need to understand resistors in parallel when circuit splits, thus provide multiple paths for the current. The total current I entering this junction A, this I split into I1 and I2. If you think of current as water current, so it's easy to understand that the total current that goes in A has to equal to I1 plus I2. Using our rules, we have total current equal I1 plus I2, but I1 also should equal to potential over R1 over R1. So I1 equals V over R1, I2 equals V over R2. So we find out that total current I actually is V times 1 over R1 plus 1 over R2. And this should also equals to V over R equivalent. So we have the equation to find out what is equivalent resistance. If you connect R1 and R2 in parallel, is given by this equation. 1 over R equivalent equals 1 over R1 plus 1 over R2. Now if we have only two resistors, then we can use a shortcut equation. Equivalent resistance equals R1 times R2 over R1 plus R2. If we have more than two in parallel, then we need to use this equation. Regardless how many resistors we have in parallel. So 1 over R equivalent equals to 1 over the sum of 1 over each individual resistance, sum up together. The equivalent resistance is always less than the smallest resistor in the group when they are connected in parallel.